In his masterpiece on the nature of things, Lucretius, 99 BC, 50 BC, a Greek Epicurean philosopher, proposed a thought experiment. He imagined a universe that is finite and a spearman standing at the edge of this universe. He throws the spear and it flies through the air. If the universe is bounded, he reasoned, it must hit something. Yet if there is something there, that must be beyond where the spear can go, and therefore the universe must be a little bigger than that. By this he reasoned that the universe is infinite. Aristotle and later Ptolemy disagreed, and proposed universes made up of concentric spheres centered on the Earth. Aristotle argued that if the stars were infinitely far away, they couldn't rotate around the Earth in 24 hours. Ptolemy made the geocentric model work, and their arguments became the basis for Christian conceptions of the universe through the Middle Ages. Nicholas of Cusa, 1401–1464, the late medieval German philosopher, started to challenge this view in his works on metaphysics. Although he had a geocentric model in mind, he argued that everything in the universe is in motion, including the Earth, with no well-defined center. He said even the outermost sphere is not a finite boundary. Therefore, the universe must be infinite. Indeed, he argued that other inhabited worlds may regard Earth as near the edge of the universe. Cusa's thought presaged the modern version of the Copernican principle, 100 years before Copernicus, that there are no special places in the universe. Cusa did not suffer persecution from the Church for his ideas. In fact, he was a bishop who occasionally challenged papal authority, suggesting the College of Cardinals should have power over the Pope. He eventually switched sides, however, and ended up an advisor to Pope Pius II. Giordano Bruno later picked up his ideas, but, while Cusa regarded them as metaphysical musings, Bruno used them to try to undermine Christian beliefs in a sovereign and almighty God. Therefore, it is no surprise that they met very different fates. Bruno was burned at the stake for heresy. Revisionist history on the part of Anne Druyan and Neil deGrasse Tyson in their episode focusing on him in the hit 2014 docutainment reboot of Cosmos attempted to paint him as a martyr to science. While it was one of the charges against him, his belief in a multiplicity of worlds and an infinite universe had almost nothing to do with his execution. Indeed, multiple historians and scientists published rebuttals of the Cosmos episode's fanciful take on Bruno, suggesting they had picked the wrong hero. Rather, the Inquisition condemned him because he argued explicitly that this meant that God had a lesser place in creation than the universe itself and denied multiple tenets of the Christian faith. Yes, he was a rather more pedestrian kind of heretic, and not the sympathetic victim as the show makes out. Now I'm a believer in religious freedom, and I certainly condemn execution for heresy. On the other hand, one look at Cusa can convince you that the Catholic Church didn't care that much about the underlying science and philosophy Bruno espoused. They cared about his promoting a theological, not scientific or philosophical framework that challenged their own. In any case, none of the arguments of Lucretius or Cusa anticipated the revolution Einstein would unleash. The Lucretian argument, for example, falls flat on its face when you note that there are many shapes the universe could have that are finite but unbounded. A sphere or torus, for example, would allow the sphere to travel without encountering any obstacle, but not allow an infinite universe. Of course, the ancient Greeks knew the Earth was a sphere, but they never expected that the universe might also be one, since they had no conception of higher-dimensional curved spaces. Einstein's theory of general relativity proved that space and time have a shape, which exposed an unspoken assumption in Lucretius that the universe is not curved. Cusa's concept of there being no special point in the universe likewise can occur in both finite and infinite universes. At present, we do not know whether the universe is finite or infinite, nor do we know if it is unbounded. There is good reason to believe, however, that the universe is spatially infinite. The reason why is that the evidence best fits a universe that is a de Sitter space. A de Sitter space has constant curvature, much like a sphere, but unlike a sphere, it is hyperbolic in shape. This gives it a kind of hourglass shape. The evidence that our universe is a de Sitter space includes observations of Type 1, a supernova in the 1990s, showed that the universe is accelerating its expansion. This would only happen with a positive cosmological constant, which is consistent with a de Sitter space. Measurements of the cosmic microwave background, CMB, by the WMAP and Planck satellites also indicate a de Sitter universe. If it were not, we would see certain anisotropies in the background. These are indications that space is not the same in all directions. We do not. The simplest explanation for dark energy, which is thought to be responsible for the universe being spatially flat, is that it is just constant curvature and that there is, in fact, no matter or energy responsible for it. This is kind of like how, when you travel from one part of the Earth to another, you follow a curved path because the Earth is curved and not because some additional force pulled you that way. The distribution of galaxies and the large-scale structure of the universe is consistent with a cosmological constant. Inflationary theory, which is a leading theory for how the universe began, where the universe expanded extremely rapidly in the initial hundredth of a quectosecond, implies a universe that evolves toward a de Sitter state. The holographic principle, which is a powerful but unproven principle in many areas of physics, including black hole thermodynamics, and the de Sitter conformal field theory correspondence of quantum gravity, support a de Sitter space based on parallels with the success of the anti-de Sitter conformal field theory correspondence. While we don't know for sure we are living in a de Sitter space, it does seem to be nearly one based on our best models. If the universe is a true de Sitter space, then that means that it is not only spatially unbounded, but infinite, since the simplest de Sitter spaces are. De Sitter spaces can have either closed or open spatial slices, so the question isn't answered completely. For example, in quantum gravity, it is not unusual to represent de Sitter space using closed spatial slices, which are all hyperspheres. It seems that, at least from our best observations, however, our universe is spatially flat, which implies that slicing is open and spatially infinite. If this is true, then the observable universe, the part of it we can see, is only an infinitesimal patch of the universe as a whole. In an infinite universe, if matter is also distributed evenly throughout, we also expect that everything is repeated an infinite number of times. There are an infinite number of Earths exactly like ours, as well as those that aren't quite like ours. This is not for any physical reason other than any random occurrence with a finite probability, if attempted an infinite number of times, will happen an infinite number of times. The edge of the observable universe is not a boundary or edge. It is simply a horizon, much like the horizon on Earth. If I watch a friend travel up to the horizon and over it, we can no longer see one another, but each of us still has our own horizon. The same is true of the edge of the observable universe. If someone were at the edge of our observable universe, they would have their own observable universe that includes things that we cannot see, because those things are beyond our horizon. It is possible that our universe is in fact still finite, but very, very large. This would be true if it is a de Sitter space, or nearly so, and appears to be spatially flat within the part that is our observable universe, but is in fact a hypersphere. In other words, we think the universe is flat because it nearly is so out to our horizon 46 billion light-years away. But it ever so slightly curves such that trillions or more light-years away it wraps back on itself. In this case, it is finite but unbounded. This would fit with inflationary theory, which would only force the early universe to become nearly but not exactly flat. In this case, we are all like flat earthers in that we think the universe is flat because we don't know any better. Perhaps when we have better instruments, we may detect a slight deviation from flatness and find out if the universe goes on forever or if it wraps back on itself. I personally would prefer the universe not to be infinite, mainly because the philosophical implications are unsettling. Could there be another me out there? I'd rather not believe it.